Hi everyone, my name is Daniel, and today I'll be teaching the workshop on Intro to Scripting. Uh, so we'll be making a web scraper this for this demo. So I suggest you watch the Intro to HTML, CSS workshop because some background knowledge in that will be required. So yeah, go ahead and watch that one first. All right, let's get started. All right, so here's the link to the slides if you want to get access to the slides, and the link to the README that has like all the info, all the code is down there. So you can click on that link. And let's go through a little overview of what we'll be going through. So first we'll go over like what is scripting, and then second we'll go over is learn why and when to use scripts. And then we'll set up Jupyter Notebook and Python. And then we'll learn about web scraping. And then lastly, I'll do a little demo on creating a simple web scraper. All right, so first, let's go over what is scripting. So scripting is when you write code that's executed by an interpreter rather than a compiler. So these scripts are read and executed line by line. So think of it like a text file with a ton of commands that you run line by line by line by line. And how it's different from compiled code is like, for example, for C++, you have to first compile your code into machine code or an executable, and then run that executable to get the output. So basically, an interpreter and scripting skips that like compile execution step and basically makes it so you can just run your code instantly. So this is different from programming because scripting is actually programming, but programming isn't scripting because programming is the process of like writing like instructions to the computer, the process of writing computer programs. So scripting is technically doing that. But scripting is like its own little like smaller subset of programming. It's kind of like how all squares are rectangles, but not all rectangles are squares. So here's some pros and cons for scripting. So scripting is typically really good for like automation data processing because you can kind of just like run it repeatedly and it's like super easy to do that. It makes development super fast because you're just writing one code and there's not like multiple like different files that you have to link together like in C++ where you have to like link different objects. But the con of that is that like it comes at the cost of efficiency because when you compile code, normally the compiler performs a ton of optimizations and we lose those optimizations and the interpreter maybe also be like really slow compared to normal. So yeah, that's when we use scripts and when we don't want to use scripts. So Python, which you've probably heard of, is a advanced scripting language that's needed for this workshop. So let's go ahead and install it. If you don't have Python install, go to this link and follow the instructions to download, and just make sure that you click Add Python to Path, like when you're like in the installation window, and run one of these commands in terminal to verify you have the installation. I already have installed it. I already know I have it, so I won't run this. But basically, sometimes some people have Python installed, so they'll run Python dash version, and some people have Python 3 installed, so they run Python 3 dash version. So if you like, oh, I installed Python, but it's not working, try the other version. And for me personally, I have a Python 3 installed, and there's not much of a difference. All right, so next we're gonna go into pip. Pip is basically Python's package manager. So to check if you have pip, do a pip dash dash version or pip 3 dash dash version, depending on if you have Python or Python 3. And basically, in like for future command examples, I won't like specify both. Just like if one doesn't work and you have the other, like use the one you have. So basically, just add 3 after the first part of the command. And if pip is not installed, just run the command python-m ensure pip dash upgrade, and that will install pip on your machine. But normally, for later versions of Python, pip should be automatically installed. So why do we need packages? So we need packages because a lot of the times like other people have created like lots of really good code into libraries, and we can import those libraries and use the code that other like really smart people have made, and that just makes our life super easy, and it's really nice to be able to use like other like common libraries, and we'll be using various libraries to create our web scraper later this demo. All right, Jupyter Notebook. Jupyter Notebook is a web application that allows you to write code, run code, and share code. So basically in Jupyter Notebook you'll have these like coding like blocks, and you can run the specific blocks that will run the code in the blocks. And after that, and you can have it output, you'll see all the like the print statements, you can display graphs, and it's really easy because you can split up your code into different sections and only run certain sections to see what goes on. And that's why Jupyter Notebook is super big in scientific computing, like or like AI computing, biology, because you can like output these graphs like that you can see in this picture, and it's like really nice to be able to just see these graphs like with like little bits of output. And you can just think of Jupyter Notebook like VS Code or any other like spot where we edit or code. So let's install Jupyter Notebook. So if you're using Anaconda, you already have Jupyter Notebook, so good for you. Otherwise, because I don't use Anaconda, you'll run a pip install Jupyter, which basically just installs, what it does is it installs the Jupyter package which other people have made for you, and it puts on your computer. I already have it installed, so I'm good. And you can run Jupyter Notebook to actually open up Jupyter Notebook. So I'll go ahead and do that right now. So I'll go to my terminal, and you can open terminal. I'm on Mac by clicking Command Space and searching terminal, and that lets me open terminal. And basically, I'm able to go here and run Jupyter Notebook. And basically, what that does is it starts up this web application that I can open, and this is my Jupyter Notebook menu. And to create like a new Jupyter Notebook like file that I can run, I'm gonna click New and Python 3. So boom, perfect. Now we're in our Jupyter Notebook. All right, so next thing we do is create an environment. So I'll come back to this slide. So why do we need to create a virtual environment? So well, Python libraries and the dependencies like this, all these libraries of code that other people have created, sometimes they get complicated because they're constantly updated by these other people. So constantly, like the packages have new and newer versions, but sometimes when you create a project, it might depend on an older version. So if we have a globally install a Python package on our computer, like on the entire computer, sometimes if we make a new project and we update a package and my older project dependent on an older version of this library, errors are going to occur and a ton of bad stuff is going to happen. So basically what we want to do is create a virtual environment, which is basically like a little playground where I can install packages, delete packages, and it'll be completely isolated from my main environment. And basically that prevents all of these like complications where there's like different versions of things, and it basically keeps my entire system clean. This is also a really good pro because you can recreate the exact environment you need to run your project, which allows others to run your project and allows your code to be deployed as well. All right, so let's go back to this slide where I go over how to make a virtual environment. So to create a virtual environment, we are going to run this command. And I have Python 3, so I'm going to add the 3 after Python. So I'm going to run. So first, I'm going to quit out of Jupyter Notebook by doing Control C, and then yes. So I'm going to create, or I'm going to paste this in, and then I'm going to use Python 3. And so basically what that did, I just created my environment. So if I look into my directory, I can see I created an environment called my-env. And then to activate my virtual environment, I need to run this code because I'm on Mac/Linux. If you're on Windows, you're going to run this. So I'm going to run this. And you can see this little parentheses my-env. That just means I'm currently in my virtual environment right now. I'm in this little isolated environment. And to leave the environment, I just deactivate. And you can see this little thing went away. Well, because for this demo, I want to be in my virtual environment, I'm gonna go ahead and run this command again. So I'm gonna be inside my virtual environment. All right. So now we're ready to start programming. So what we will be creating is a simple web scraping script with Python when you run it and it grabs data. So first, what we'll do is send an HTTP request to retrieve a web page. Then we're gonna parse the HTML data of that. Basically, the web page is all the data to find relevant info. We're gonna handle pagination, and then we're gonna handle the data. And if you don't know what any of that is, don't worry, I'll go over it in later slides. So first, what is web scraping? Web scraping is when we use automated tools or scripts to extract data from a website. Whether it's that you can get the text from the data, the images, etc. And it's usually in HTML, which is like hypertext markup language. It's how websites are formatted, and it contains all the data. And processing that data into a format that you need. So say like, I don't know, I want to scrape all of, the listings of like cat toys on like Amazon or something. I can grab that data into a form that I can use. So common web scrapers are, or that can be used just for market research, like stock market research. Bruin Dining uses a web scraper to get all the data for like what dining halls are open, news aggregations, AI agents, etc. And this is done throwing libraries like Beautiful Soup and Scrapey, and we'll be using Beautiful Soup for this demo. They basically, it's just a ton of like code that other people created that makes it super easy to send requests and grab data. All right, so how will we web scrape? We will be using Beautiful Soup, as I said, which is a Python package that is able to extract HTML data. So in Jupyter Notebook, run this command, which, so let me go ahead and run that. So let me restart up my Jupyter Notebook. instance. Perfect. And I'm going to want to create a one of these new files. The other one was demo. So I'll be in my environment, and then I'm going to run this code. So let me get rid of some of these. So I can run this. I'm running it. And so basically what I just did is I just installed request and beautiful soup. Actually, I should run this pip. So yeah, I already have it, which is perfect. And then so let's go through what I just did. So what I just did is I installed the requests library and installed the beautiful soup library. What request does, it allows me to make requests to a web page and grab its HTML data. Beautiful soup lets us go through all that data and extract what we need. So here's a quick little code example from Wikipedia that uses requests and beautiful soup. So basically, from this URL, which is Wikipedia, it'll do response is equal to request.get from the URL. So request.get basically gets a response object that has a ton of things and also contains all of the HTML data in response.text. So if we instantiate our beautiful soup and do soup equals beautiful soup response.text HTML parser, this basically allows us to go through all of this HTML data from the Wikipedia page, and headings equals soup.findAll div just finds all of the div HTML tags in this response.text and basically allows us to find all those tags, which is super, super cool. So, so to go over a bit more about HTML, let's look at the website that we're going to be scraping, which is bookstoscrape.com. And if we double click, right click, and you go to inspect, you can actually see all of the HTML data that like displays in this page. So this page is basically all this HTML data. And so what our Wikipedia code just did is it looked for all these divs, these div HTML things, and it grabbed all of that data. And Chrome tools is super powerful, and it kind of basically allows us to figure out like what parts of this data do I need to scrape to get the data I want. So for example, for this website, there's a ton of books, so I can double click on it and click inspect. And I can see this is where, the image for this book is. This is the image container. I can kind of just like look through and see like where I would get the data, where I would need to find, where I can find the data that I need. All right. And here just comment some common HTML tags you'll see. And you can kind of look through this in your own time. Well, like it's where you find images, find paragraphs, etc., etc. And now let's go through pagination. So pagination is when all the data isn't displayed on a web page. And if I go to this website again, you can see that it's page of 1 of 50 and not all the books are displayed. I have to go to the next page to display this. That's basically all that pagination means. And later on in the demo, I'll go over like how we can handle pagination for this website specifically. All right, so now it's perfect. Let's go to our Jupyter Notebook demo where I'll be creating this web scraper. All right, so first off, I already pre-wrote all this code, so I'll be copy pasting like sections of code and explaining it. All the code that you need will be in the GitHub link in the bottom of the slides. So the first block of code I'll paste in right now. All right, so let's go through what this code will do. So import requests, import beautiful soup. This basically just imports these two libraries that we installed. And some other libraries that we need is CSV. CSV is basically means comma separated values. It provides a nice way. It's basically like a file type. It basically gives us a nice way where we can like display and download all our data. And the time we'll be using so specifically .sleep, which basically pauses our application for a short while. And we'll need that later on because when we send a ton of requests to HTML pages, basically we don't want to be sending like millions and millions of requests to a page because we'll get timed out, errors will happen. So we want to, do a little pause before we send all the requests. And then here, I'm creating the base URL. The base URL basically just contains the website we want to scrape, and slash page slash curly braces HTML. The reason why I added this curly braces here is because if we look at the link, the page is enclosed. So if I want to go to page 2, it would be a 2. So later on, we'll format this to a different number in order to go to the right page. That's how we'll handle pagination later. And the next thing we'll go over is handling the rating. So the rating is currently formatted as a word like one, two, three. So basically what this function does is it uses a dictionary to map the word to the number itself because it's nicer to process numerical data. And what this here does, it basically just returns a numerical rating, and if there wasn't a numerical rating, it defaults to zero. So let's run this code. And basically what I'm running this code just imports all of this and defines this little helper function that we'll need. So let me next uh copy paste the next block of code that we'll need, which will contain most of our scraping logic. All right, so here it is. So I know it looks like a lot, but let's break it down line by line. So this basically just defines a function scrape book page with the page number. So first of all, we're gonna format our URL using dot format page number, which basically replaces these curly braces with the page. So if it was one, it'd be page-1.html. And then next, we're gonna send a get HTTP request to grab a response object from the URL. So we do response equals request dot get URL. That gets us our response object, and our response object contains many things like the HTML, raw HTML text, and it also contains a status code, which tells you if it's successful or not. If it was 200, that means everything is good. So I have this little check here. That's like if the status code is not 200, which means something failed, that means we either have like a typo in our link or there's some internet connection issues. And basically there's an issue with fetching the page. So if everything goes through and we get a response code 200, we'll be good. So next we'll create the beautiful soup parser with response.text, which is all the raw HTML data, and HTML.parser. Basically what HTML.parser does in the second parameter is basically it creates a parse tree, and you don't really have to know what that means, but basically it just makes it so that like Beautiful Soup can efficiently look for the specific things that we need. It's an efficient search algorithm. We don't have to know too much. Just know that it works very nicely. And the next thing we're gonna do is we're gonna create this book list variable. And we use soup.findAll. Find all basically it looks for this first parameter, which is the tags. So what it will do is it looks for all of the article tags like this. In the Wikipedia example, we look for div tags. In this case, we're looking for article tags. All article tags with the class product pod. So product pod is normally used for like styling or CSS, where you can like classify different pods. In this case, every book is contained in a product pod. So in this case, we're looking for all the articles with the product pod class, and we're turning this, putting this in the book list variable. Basically, what this does is it finds all like the pods of book lists. And then here we're gonna create a results array, where we'll store all of our results. And for every single book and book list, so we're gonna loop through all the books in the book list that we've had here. So we're gonna loop through all of these article, product pod sections, and we're gonna extract a few different things of data. So here we're gonna extract the title, here we're gonna extract the price, here we're gonna extract the availability, and here the rating. So first, let's look through title. So first, we're gonna grab the title tag by doing book.findh3. .findh3 basically looks for all h3 tags. So like this, if this was h3, it looked for that tag, and then it finds the a tags under the h3 tags. And basically, what this code does is it will look for the title attribute. So if you look here in this example code, it doesn't look for the actual code that's displayed on the text, which would be click here. It looks for this title attribute. So this, and in the website itself, the title attribute is actually what contains the name of the book. So then we're gonna store this title tag, and if we didn't find a title, we're gonna store no title found. So that's basically how this works. And for price tag, we're basically do the same thing. Find the p tags. So this will be p, where the class is price color. And what this does, it basically, the price is actually contained here, like actually displayed on the website. So this will actually find like the prices displayed on the website. So it will be this actual direct text. Same thing for availability. We'll do dot find a p, but instead of the class being the price color, because see how the price color is green? That's what CSS or like styling was used for this. That's how we can like locate it. But for in-stock availability, it will be this class, and we kind of do the same thing. We extract the stock text only, like whether it's in stock or not. And if it's not, we say NA. Last thing we'll extract is the rating. So again, we're gonna find p tags with the class star rating, and then here we grab the rating class, whether it's 1, 2, 3, etc. And then if there are no ratings, then we say no rating. And this here uses our helper function over here, define over here, get rating, that like takes in, 1, 2, 3 and returns a numerical value. And at the end of the loop, we're gonna append all the stuff we found to results. So results.append, we're gonna append an object that contains the book's title, the price, the availability, and the rating. So basically, it'll be a ton of book objects that has all the information about the books, and we'll return these results. And we'll have one of these objects for every single book because we're looping through all the books. And so here's just some little test code that I wrote. Basically, it scrapes from this website only page one. And so if we look here, there's a four, it's 4 by 5. So we should get 20 books. So scraped length of this sample books array, it should be 20 to ensure that we got everything. And this, what basically this does is it shows the results of the first three books that we scraped. So if I run the code, so we scraped 20 books from page one, which means it's good. We got all the books that we needed. And you can see that the first book is scraped is A Light in the Attic. It costs this much money. It's in stock and has a rating of 3. If you look, it's like that's correct. Light in the Attic, 3-star rating, this price, and it's in stock. So perfect. We were able to scrape the data from a website, which is super super cool because all this program literally like got the data from the website itself. So next thing we'll handle is pagination. So let me copy over the next block of code. So what this does is it basically defines the function scrape multiple pages, and you pass in a start page and an end page. Basically, this will, at a really high level, this will call our scrape book page function, which will scrape the data from the book, from the page, but it will repeatedly do that for every single page. And basically, you can see for page and range. So basically, we're gonna loop if it's 1 to 3, it will do 1, 2, 3. It'll scrape all these pages, and then we'll print scraping page to show we're scraping that page. And then page will store in page books the data that we scraped using our scrape book page function. And then here I have this polite delay, which basically puts our request to sleep because say we did 1,000 pages. Every time we access a new page, we're gonna send a book, or we're gonna send a request, right? And we don't want to be sending a ton of requests. That's where this time.sleep comes in. That's where this import time comes in. And basically what this does is it just grabs all books.extend, just basically creates an array of all of the books from every single page. And so here's some test code that we have. So books data is scrape multiple pages, 1 and 2. So we're going to scrape from page 1 and page 2. And then because there's 20 books per page, we should expect the length to be 40 if everything went well. So let's run this code. So scrape page 1, and you see how there's 1 second delay. Then we're scrape page 2, and it's good. We scraped 40 books, which means that we successfully scraped all 40 books, which is perfect. So it accessed page 1 first, then page 2, and it put all the books in this all books array. Perfect. So now that we're able to scrape all the data from the website and handle multiple pages, let's put the data in a format that can be easily used by like another program. So this is where the .csv library comes in, and let's paste this code in. So here we create a function save to CSV, where it takes in a list of books and it saves it to the file books.csv. So a CSV is comma separated values. It's basically like has a set of rows and columns, and all the values are separated by columns. If you looked at it, it's kind of like a Google Sheet. If you looked at it, it's basically a ton of columns and rows, and the field names are basically the columns because we have each book has a title, a price, availability, and a rating, and the rows are the books, and then so it'll go down. So if we were to create a CSV with the first 2 pages, would have 40 books, and then each one would have a title, price, availability, and rating. And what this code here does is it basically just loops through all of the books, and it just writes all of the data, all the title data, price data, availability data, rating data, and it saves it to a books.csv file. So let's run this code because I'm calling the function here. And it says data saved to books.csv. So then if I go into my Finder, I'm in the script.demo, I can see, oh, perfect. It created the books.csv file. And if I open it, it's going to take a second, but, oh, I've been too, but we you can see that all 40 books were created. It says 41 because the first one is the headers. But you can see the first one is the light in an attic, and it has all the data, and it has all 40 books and all of their data. So there we go. We successfully scraped website data, handled multiple pages, and then we saved it all to a .csv file. And later on, maybe like I wanted to filter out some of the data, like, oh, I only want books that are less than this price. I can then go ahead and read my CSV file and then process that CSV file so I can get the data that I want. So that concludes our demo, which is really cool. All right, so next thing I want to go into are some final caveats. So my current demo was a very 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 simple example. This website, if you didn't tell, it's called Books to Scrape. It's basically built to be scraped because so it's like very easy to scrape. But nowadays, a lot of modern websites have measures to prevent web scraping. So if you've ever seen like web captchas, like "Oh, prove you're not a robot," those can prevent these like the request.get. So it prevents us grabbing the HTML data. And another thing is that a lot of the times, web scraping is actually not ethical. Make sure you only scrape public, freely accessible data, and you're not scraping like private data. Also, another thing to watch out for is a lot of the times a website will have a robots.txt file, and that basically just explains what parts of the page can be scraped. So make sure if a website does have that, you read into it and ensure you follow it. Another thing is our web scraper was super simple. Well, actual web scraping on like websites can be very hard because there's a lot of times where things just go wrong. For example, in this demo, all it was really nice because all the books were like in the HTML data. We can just grab it, it's super easy. But a lot of times, other websites may use dynamic loading or like infinite scrolling, or basically you have to scroll down through the entire page in order to load the data. So the data is not actually loaded until you scroll down. So in that case, the HTML data only contains fragmented data. It won't have all the data. Database fetches where a lot of times the data isn't actually like stored on the website. It's like it's fetched through another like through the database a database call, and in that case sometimes you're unable to grab the data for pure HTML data because the data won't be in the HTML tag, or if like I've seen some examples where I try to make web scrapers where like the website was actually like an app in itself, and the HTML data had like no information, so I was unable to do anything. And in those cases, more advanced web scraping methods are needed. And my very very basic example where I assume everything is in the HTML data, everything is as I need, won't really work. And another thing is that if I have to use the Chrome Dev Tools, which I went through earlier, and that's what really helps us find like in the HTML data like what I need and where I can find what I need. So yeah, that's how to create a simple web scraper script and a bit about scripting. And I hope you enjoy the rest of the time you're HOTH and happy hacking. Thank you.